Good morning. I'm back here with another video, and today I'm going to talk about feed-forward neural networks, which are the most basic form of neural networks. So our first thing I'm going to show you is an extremely basic neural network that has no hidden layers, therefore is not actually considered deep learning. So we've got our our input nodes. I'm just choosing 3, but you got the input nodes all feeding into the output node. And this right here is not new. I believe this has actually been around since the 70s, if I'm not mistaken. Anyway, as you could guess, they all feed into the output, produce the output, which then you take the desired output compared to, subtract the output, and that is what the error is equal to, and then you take the error times the output that we get, this output is regularized as a sigmoid. Regularized as a sigmoid, which puts everything on a scale of 0 to 1. So keep in mind, it's not just the output, but the output with the sigmoid acted upon it is equal to the delta, or the change that is implemented, the change that is acted on this output, and then you basically go through this process as many times. This is called an iteration, and you iterate through this process as many times as you set it to. And I believe as you look into my code, I will set it in the tens of thousands range somewhere. So that is all that a neural network is in its most basic form. However, realistically, no one actually uses this except for probably just like beginner demos like this one. What is actually used is the use of hidden layers. This is what turns this into deep learning. Without it, it is just a neural network. And black. Anyway, so if you will, each input node will visit all of the hidden nodes, which is currently set to 4, as you can see. Boom. All going into an output. And then the output is compared, and we do once again we do this error is calculated, and then the delta is calculated. Just like, however, we do not just go back and do this iteration. This right here is called forward propagation. We're not doing that. We do what's called backwards propagation, or back propagation. And we do this exact same calculation to find the delta. However, the delta is factored in with the weight of each neuron. These are called neurons, by the way, and the weight determines, it's kind of like firing power, if you will, kind of like the firing power, kind of like the firing of neurons in the human brain, actually. Anyway, you go backwards with this, going backwards into the hidden layer, and this delta with that is going backwards is how you compute, or how you find the error for the hidden layer, and then that error is taken through the exact same process to find the delta, and then that delta goes through the weights of the previous hidden layer. Now, for this case, there's only one hidden layer, but if there were multiple hidden layers, it would go through every hidden layer until you get to the first hidden layer, but it would not do this for input because you do not change that input, obviously. Anyway, that is my explanation on how these networks function. Now I'm going to show you the code. Actually, really quick, before I even show you the code, I'm going to explain kind of in the code, as you can see. We have input layer, hidden layer, output layer, and then we find what I was just talking about right here for the output. And then as you can see, we go back for the error and delta of the hidden layers before the weights are updated, and then we print the final output result. Okay, now time for the code.